Let me write it up the formula here. Our formula is sigma x prime theta equal to So these are our formulas. This is the Mohr circle, and here, for example, here we're given the status of the stress, the 2D, is a 2D stress. So if we given like this, then for example here, this is x, and that is a point y that representing. The x representing is the stress on the x in the x plane, that is sigma x and tau x y. And y is the stress on the y plane, that is sigma y and tau x y, like this. Okay. So that basically is here and there. And so that is a point we know we can build up the Mohr circle, and here the Mohr circle we can build up carefully. So that is the center. Let me use the. Okay, how about this? So this is the center here. So here I use my ruler because I want to precisely measure the things. So here. So from here to here is our sigma average divided by sigma x plus sigma y divided by 2. And from here to here is our sigma x, and from here to here is tau xy. And I don't know whether the circle you draw is small or you should draw a little bigger. Okay, here I have my stencil. So from y, we measure from here to here is sigma y. And then from here, we measure to here is tau xy. So that is the information we get it from the build-up of Mohr circles. And now for the transformation. Say, for example, here, for the transformation on the Mohr circle is this. Say, for example, if we like to do the transformation on theta, and that is a formula we can utilize. And remember to put a sign convention. So here to draw this one, so that is the new stress element. So here is x prime, y prime. And so here is tau x prime, tau x y prime. And then that is the shear stress, sigma tau, etc. like this. Okay. So made it up on the Mohr circle is, again, last time I tell you the rules, a few rules. And last week I mentioned to you that are the rules you just memorized. And that is the reason I want to give you now. So the first rule is this: when we on the stress element, we rotate by an angle theta. Corresponding on the Mohr circle is twice 2 theta in the same orientation. So why not here? Say, for example, if you look at the two triangles, okay, and then I want to make the triangle rotation here. So here again, we rotate in the same sense by 2 theta. So for example here, let me rotate to here. Okay. So rotate to here, let me draw it carefully. So basically from here, hopefully you can see that clearly. So here, these the two triangles are translated from the original one, and the angle basically is side from side. So from this side here is 2 theta, and which means this angle is 2 theta. Okay, so again, we take the first rule is whatever on the stress element, when we decide how much angle we want to rotate on the stress element, that is the 2 times of that designated angles in the same sense on the Mohr circle. And that is the first rule I ask you to memorize. And saying in doing this way, then we guarantee on the Mohr circle here, for example here, right now we rotate in this way. This is meaning x. We rotate the diameter, which means equivalent to say we rotate the 2 rigid triangles into this way. So that means x move to here. That is x prime. This is y prime. As far as we can figure out the coordinates on x prime and y prime, that represent is the status of the stress on the transformed element. And now I'm going to show you why. Why the coordinates of the 2 new points represent the status of this one, I'm going to show you. And by doing so, we can try to work out symbolically the coordinates of x prime first. And doing this one, that be a little bit, we'll have to use our things carefully. That one can be done by this. So that reason, I don't know whether your circle is big enough. I'm going to put something here. And this is the same. Let me write up here. So right now, x prime will be equal to this one. The first one, through this point, I put So from here you can see very clearly the coordinates of x prime, and that is sigma x prime and tau x prime y prime. The coordinate is this piece, 1 plus the second one plus this one, right? Okay? So what is this piece?
So it's
The x prime, the coordinate, right now I'm focusing is this one. The coordinates of this one is equal to this one.
you could do the triangle, right?
Yes,
The little
but
triangle
this
with the
one.
green side and
Yeah.
the blue side and the black side.
Yes. So for this piece, this one, if we utilize this triangle, look at that carefully. And what is this? This one equal to this one, right? This one is equal to how much? Is this one? That one is equal to sigma x minus average. Are we okay? What is this distance? The distance is the sigma x minus this one. So basically that one is sigma x minus sigma y divided by 2. Are we okay?
That's the blue side? Yeah.
Are we okay? So therefore, this one is how much? Sigma x minus sigma y times cosine 2 theta.
To the green, right?
Green, yes, that is green. And this piece,
It's the sine thing.
this one, if we will be utilizing this triangle here, which triangle? If we utilize this triangle, and this is 2 theta here. So in this way, and what is this? This length is transformed from here to here, right? And what is that? That is tau xy. So therefore, this one is tau xy times sine 2 theta. Okay?
How can you say that that 2 theta is equal to 2 theta again?
This is 2 theta.
Yeah, how can you say that again?
Because this one, this angle plus this angle 90 degrees, this angle plus 2 theta 90 degrees, so this angle equal to 2 theta.
And the
Again, this is 90 degrees here.
Yeah.
And these 2 theta, this angle plus this angle equal to 90 degrees, this angle plus this angle equal to 90 degrees, so therefore this
Okay.
angle 2 theta. So from here you can see the 3 pieces added up together will be this equation. Can you see it? So that means once we transform on the Mohr circle, at least we get this one done, and then we go to the second one. For the second one, that is okay, so we're looking for, this is our tau x prime, y prime here. And what is that? That one
So you're just proving the equations with Mohr circle.
yes. Right now I'm providing you
Okay.
the reason why the rules is like that. Okay. And what is this one? Basically, if you look at this, look at these sides here. this side equal to how much? This side is equal to this side here, okay? This side equal to, using the right triangle, this side equal to tau xy. And again, I want to calculate the length of this side. I utilize the right triangle here. So that will be equal to tau xy times cosine 2 theta. And then what is this side here? For this side, I utilize the green triangle, and that's equal to this one. So what is that one? That is equal to the side length times sine 2 theta. Okay, so therefore, the magnitude is equal to the difference. This magnitude equal to the difference of the two pieces. So that would be equal to tau xy. Okay, and then in our corner systems, for example, here for that is a little bit ambiguity here. That is saying from here you can see right now at least the magnitude of this equation basically fit into our case here. So now we want to try to get the one. Oh, that is exactly the same like this one, right?
Yeah.
Okay, so right now here we prove this one. Are we okay? So, and you can repeat the same thing for this point, but we can ignore the detailed calculations. So therefore, from here, not only on the Mohr circle, the conclusion is this. Is as long as we designate our angles in certain sense, we on the Mohr circle will rotate in the same sense by double of that angles. And then we simply work out graphically on the coordinates of the new point. Then we will be able to, it's equivalent to say we calculate the magnitude in terms of equations. And here we can utilize one example to demonstrate. And that is the same example we used from the beginning. Okay, so for this example, say if I want to go for angle theta equal to 49 degrees, so if it's 49 degrees, I want to calculate the corresponding side here. I run out of space. Let me do that carefully. Smaller x prime and y prime. So I want to calculate sigma x prime, sigma y prime, and tau x prime, y prime. So for this example, we can draw the Mohr circle using the techniques. So first we calculate the average is 10 plus 4, 7, and r is equal to sigma x minus sigma y. Divided by 2 squared plus tau x y squared, and that'll be equal to 5. So for this case, the Mohr circle is like this.